Okay, so today we are going to be looking at the network address translation. We had started on it the other day, and now we want to go ahead and look at it also in detail. I don't know why my screen is not full, but we shall just continue. Okay, so we're going to be looking at network address translation. Let me move to the next slide. Okay, so network address translation translates an IP address carried in the header of IPv4 packet into another IP address. Generally, the NAT is used to translate IP addresses into public addresses so that devices can communicate across private and public networks. To alleviate the public address shortage caused by internet expansion, the NAT emerged as a temporary solution. Previously, as you're all aware, maybe you just had a few devices connecting to the internet, and it was okay to assign each IP, each device a public IP, and you're able to connect to the internet. I should mention that for you to be able to connect to the internet, you need a public IP address. So that's why each device that needs to communicate to the internet must be assigned a public IP address. But what is the world population today?
We are many.
Over 40 billion.
Over 40 billions. And how many IP addresses do we have available?
4 billion.
Only 4 billion. And the people are over 40 billion, right? So you can imagine, what were these people going to do? Of course, the first people who designed this kind of technology, it was okay because by that time there were a few people who are connected to the internet. There's also another solution of IP version 6, which has been put in place, but it still has a long way to go because most of the devices today are still relying and are still using IP version 4. Of course, IP version 6 gives us so many IP addresses that we shall never be able to consume, at least in the next generation. Maybe the people who will come after and after and after us, they'll be in position to say, like, what were those people thinking about? IPv6 is no longer enough. Let us come up with another, with another way of making sure that we communicate. Because IP addresses are not enough, these guys were clever enough and they decided to, divide and categorize our IP addresses into private and into IP address. And the purpose of private IP addresses so that they can be reused, isn't it? So that they can be reused. I forgot my writing tab, so I'll just chill with writing. So they can be reused on the internet. We have different classes. We have class A, we have class B, and we also have class C. And class A, I think, starts from 10.0.0.0 to 10.55.55.55. Class B starts from about 172.16 to 0.0.0 to 172.32.55.55. Class C starts from, I think, 192.16.0.0 to 192.132.255.255. So that is the range of our private IP addresses, but still they're not enough. And for that purpose, that's why these people decided to come up with this NAT mechanism to help us translate these private IP addresses within your internal organization so that it translates them to a public IP address, which public IP address can now be reused or can be used by those devices to access information on the internet. Okay, so upon completion of this course, we shall be able to recognize NAT application scenarios, understand how NAT works, and configure NAT on firewalls. So let us look at the NAT principle. Okay, let us look at the NAT principle. Like we said, to date, IP version 4 addresses are depleted, right? They're not enough. They're basically not enough. And IPv6 cannot completely replace IPv4 immediately, and technologies to mitigate IPv4 addresses exhaustion, NAT, for example, continue to emerge. So that is one of that technology that they have come up with to make sure that they leverage on IPv4s and to translate them into all IP addresses which we can use today. So NAT cannot IPv6 cannot immediately replace IPv4 because certain workarounds require to extend the use of IPv4. That's why today we have different kind of technologies. Class A starts from, I already talked about that. And class C starts from 192.168.0.0 to 192.168.255.255. And public addresses are used on private networks, whereas public addresses are used on public networks like the internet. So for you to be able to access the internet, you need to get a public IP address. And that IP public address is usually assigned or given to you by your internet service provider, your ISP. So to allow communication between private and public addresses, the NAT must be used to translate your private IP address into a public IP address which can be used on the internet. Okay, so what are some of the advantages and disadvantages of our IPv4? So in addition to the reuse, NAT continues to evolve and it provides other advantages. But the main advantages of NAT is that it enables us to reuse IP addresses. So IP addresses can be reused. And it also, why IP addresses can be used in my private network or in my private company, I can use the same range of IP addresses. And also right now, wherever you are in your private network, yeah, you could be or probably using the same range of IP addresses. Even another company A, even another company B or C, they're able to do that. But when you want to all go to the internet, we have maybe one or a pool of public IP addresses, which will be mapped to our private IP address, and then they will be translated into our public IP address so that our devices are enabled to access the internet. So numerous hosts on our local area network can use few public addresses to access our external resources. And internal or World Wide Web, let's say like the file transfer protocol and the internet services can be used by external networks. Also, the address translation process is transparent to the users. For you, when you're using and when you want to browse, you don't know that actually your IP address has been translated. All you do, open your browser, go to your email, send out emails, watch a few videos, and you don't know whatever is taking place. So it is transparent, and internal and external network users are unaware of the IP address translation process. For you, open your computer, connect to your internet, and then you're good to go. Sign in if you must, and then you're good to go, and then you have access to all the resources. There's also privacy protection. It's available to your internal users because you know the internet is unsafe. There are so many people, and that's why you have your firewall at your egress. You have your firewall at the entry of your network to protect you from that unsafe or untrusted zone. Now, because of that, because of NAT and that translation, hackers out there, they're actually unaware of your topology inside your network. They're unaware of that topology. Why? Because your address is translated and they actually don't know the real IP addresses to your internal servers within your organization. There are also multiple. It helps you to to conduct out load balancing among internal servers. It's available. So because of this technology, multiple internal servers can be configured for load balancing, and this helps to reduce the pressure of each server in case of heavy traffic. The disadvantages are network monitoring is difficult. So if you're trying to monitor, let's say your network remotely, because of this translation, sometimes it makes it difficult for you to monitor your network, and that cannot be performed if the packet header is encrypted. For example, for an encrypted FTP connection, the port command cannot translate IP addresses. And then also some applications are restricted. Network supervision becomes more difficult. Also, tracing a hacker who hacks a server on a public network from a private network is difficult. Why? Because we already said that it protects his privacy, which is available to internal users. So if this hacker out there, you're unable to trace back to him directly, because also his IP, if he's using NAT, it is difficult to know the private network where the attack came from, because the IP addresses of the hacker has been NATed. I hope we're on the same page. Let us look at the basic principle. Basically, or generally, the best principle is that how are we able to translate our source IP address into our public IP address? So just excuse me, just briefly. Sorry about that. We are saying here, could someone please mute your microphone?
Mute.
It's turned on call.
Are we making noise or what?
I don't know what also happened. People were just excited about, I don't know what. So we are saying the best principle of NAT, that it translates the source and destination IP address into an IP packet headers, so that numerous private IP addresses can access the public network through a limited number of private, of public addresses. So NAT translates the IP addresses into the packet headers to other IP addresses, so that users on the internal network can access those external networks. Generally, every NAT device maintains an address translation table. So the IP addresses of packets that pass through our NAT device and require address translation will be translated against the table. So NAT mechanism involves the following process. One, it's going to translate the IP address and port numbers of the internal hosts into the external addresses and port numbers of our NAT device. Also, it's going to translate our external addresses and port number into IP addresses and port numbers of internal hosts. So that is the NAT implements translation between our private address, port number, public address, and port number. So NAT devices are located between our internal and external networks. So the packet exchange between our internal hosts and external servers all pass through our NAT devices. So common NAT devices include routers and firewall. Those are some of the common NAT devices. So as you can see here, we have our example. We have an example here. We have our internal user who is on an IP address of .1.1.1.1, and he wants to communicate and send packets to our FTP server, which is on the IP address of 192.123.2.3. Yes. So we have our firewall, and this case is going to act as our NAT device. So when this guy wants to send packages to this guy, or he wants to, to establish a connection, he's going to have, remember our quintuple, he's going to get all those details, but part of those details is the destination IP and the source IP. What is the source IP? My IP address. What is the destination IP? The IP address of my FTP server, right? So it's going to go ahead and send those devices. When they get to our NAT server, remember it's now going to get these guys and it's going to translate them into the public IP address. It's going to translate them into the public IP address. So we are seeing here, this guy also, his table, he's saying, you know what, I want to translate my, put this away. I want to, this guy is saying, translate destination public IP address into private IP addresses. This one is saying, translate private source address into public. So when he's sending, this firewall is going to translate, and it's going to convert our source IP address or translate it into an IP address, which is meant to go all the way to our FTP server. And they're going to use the public IP address. And the same will also happen to this guy when he's trying to send back the package to our internal user. Okay, it's going to send it back to our internal user. So moving forward to the next slide.
Mr. Sengi,
Yes, please.
does Microsoft Windows Firewall do the same?
Does Microsoft?
The firewall, does it do the same functionality? Does it have a NAT on it?
Yes, yes, yes. It has the NAT functionality. So let us look at the address or the NAT categories. We are generally categorizing them into two. There's a NAT source and we have the server mapping. So with the NAT source, we are seeing that the NAT is divided into these categories, 1, 2, 3, which are 3 categories. And they are based on the application scenario and what you want to achieve as a network engineer or as a security engineer. So 1, we have our source NAT here, and our source NAT enables multiple private network users to access the internet at the same time, right? It enables multiple private network users to access the internet at the same time. And in here, we have those 2 categories. 1, the address pool mode, and 2, the outbound interface address mode, which sometimes people call the easy IP. So the address pool mode, here, the public addresses in the address pool are used to translate users' private addresses. This mode applies when many private network users can access the internet. So what happens here, you have your pool of public IP addresses, and when users try to communicate, they're able to send packets, they're able to map their IP addresses directly to your public IP addresses. Excuse me. Sorry about that. So I was saying in the address pool mode, basically we have public addresses in our address pool that are used to translate our users' private network. So we have a pool, like you hear the word pool, of public IP addresses, which pool is used to translate our private IP addresses. In the outbound interface address category here, which we are calling also the easy IP, the IP addresses of internal hosts are translated into the public address of an outbound interface of the public network. This mode applies when the address when the public address is dynamically allocated, and we're going to look at it in detail. And then the last one, or the third one, is a static mapping, or sometimes people call it the NAT server. So here, with a static mapping or the NAT server, it enables external users to access servers on a private network. Static mapping happens or maps one private address to one public address. This mode applies when public network users access servers on our private network. Okay. All right, let me clear my screen. We look at now the source. We look at the source. We look at the source NAT, right? Okay, let us look at the source NAT. We said with the source NAT, we have our mode 1, which is the address pool mode without port translation. There's one without port translation. And what this basically does, the source NAT translates the source IP address, that is the internal host IP address, your private IP address, in an IP packet header into the public address. This enables numerous hosts to access the external resources through limited public addresses and efficient and effectively hides the host IP address on the LAN. So the address pool mode without port translation, we are also going to look at it without port translation, is implemented using NAT address pool, and it contains multiple public IP addresses. Only IP addresses are translated and only one private IP address is mapped to a public address. So if all addresses in our pool are allocated, NAT cannot be performed for the remaining internal hosts until the address pool has available addresses. So this is our address pool mode without port translation. What happens? We are going to get our internal IP addresses and we're going to translate it into our public IP addresses. Remember, our internal is usually in the trust zone and the internet, or our external network is usually in the untrust zone. So we're going to get our private IP address, which is like 192.168.0.11, and it's going to, the destination is going to this, destination, which is 1.1.1.1. But then our firewall or our net device or a router or whatever device you're using to translate, it's going to translate it into 9.9.9.9. So you're going to have a pool of these public IP addresses, which will be translated and it will map it to that. And the same will happen when also the packets are coming from the internet or are coming from the external network to your network. So what happens, this is an illustration of the one-to-one address translation is performed without port translation. So we have our IP address. We have, this is computer A, this is computer B, this is computer C, computer D, and they want to access. So what is going to happen? Each private address, like we have said, is mapped to one public IP address. That one will be taken. It can't be used by any other computer until this guy releases it, until the NAT device releases it. Also, B is going to be mapped to this public IP address. And also, C is going to be mapped to this public IP address. So if you have a pool and you only have 3 public IP addresses available in that pool, when another client wants to access access the internet or external network, his packets will be discarded because there's no IP address, public IP address available for computer D to map his private IP address so that he's able to access the the external network. So that is a problem. This kind of mode is expensive because it is expensive even getting one public IP address from your ISP. So imagine you have to buy and you have to purchase all these IP addresses. Habakkuk, your hand is up. Is everything okay?
I want clarity on something. Yeah.
Yes, please.
When doing one-to-one NAT, when, for example, I use a public IP of 155.133.87.1, then mapped it to the 22.168.11. Can I use the same public IP to access the web UI of the firewall device?
We are still on the firewall. Just repeat your question again.
I'm saying, for example, the first IP here, 192, though it's mapped to the public IP.
Yes.
Can I use can I use the same public IP to be able to access a web UI?
I'm not getting your question very clearly. I don't know if it is
Okay,
my network.
let me just write it on the
Chat, eh?
chat.
Okay, that would be very,
Yeah.
very helpful.
Okay.
All right. So let us continue. I want us to get done with these slides a bit easy. So those are some of the disadvantages of that particular mode. That if in case your public IP addresses are not enough, other devices that want to access your access the external network will be blocked out because there's no private IP address. Now let us look at the mode 2 for address pool with port translation. So the address pool mode with port translation is implemented using a NAT address pool that contains one or more public IP addresses. And addresses and port numbers are both translated so that the private addresses share one or more public IP addresses. The beauty of this is that so they do what? They share either one or more public IP addresses. So because the addresses and port numbers are both translated, multi-users on a private network can share one public address to access the internet, and the firewall or the NAT device or the router can distinguish users based on their port numbers. So numerous users can access the internet at the same time. This technology uses layer 4 information to extend layer 3 addresses. So theoretically speaking, you have about 65,535 private addresses that can be translated into the same public address, because 365, I forgot my writing pad to office, so I'm unable to write. Ports are available for each address. So the firewall can map data packets from different private addresses to different port numbers of one public address. So compared with one-to-one, the previous one that we looked at, this multi-to-multi address, this mode is greatly improves our IP address utilization, and therefore the address pool mode with port translation is mostly commonly used. Okay. With port translation, this address pool mode is commonly used. We can either use one or we can use many. All we do is just get our source port, and we also translate the source port to Y, and we're able to send a packet. So we can use this one public IP address. We get also another packet, and we just translate the port and we map it. Just like you see, we have our client A and it's trying to communicate to our, let's say, server somewhere in the cloud. And so here, the different private IP addresses are mapped to the same public address, but different port numbers to implement many to one address translation. The other one we looked at is one-to-one. This one we can have multi or many to one translation. As you can see, these are our private from device A, device B, device C. Here, as you take keen notice, is that we are using one public IP address, but we are using different port numbers which are being translated, and then we are able to access our external network. So moving forward, just excuse me briefly. All right, so let us look at EasyIP, or the outbound interface address mode, the EasyIP. So easy IP, which was in our third category, we are looking at our outbound interface address mode, which we're also calling the easy IP. So it translates private addresses into public addresses of the outbound keynote of the outbound interface without the need of configuring a NAT address pool. So with this kind of category or with this kind of mode, addresses and port numbers are both translated so that the private address share public IP addresses of outbound interfaces. As you can see here, we can configure it so that they share this guy, but of our outbound interface. So this is called also easy IP address. So let us look at the NAT ALG. The NAT application level gateway, the ALG, is a translation proxy, keyword proxy, and it is used for certain application protocols and can translate the address port and port number carried in application layer data. Okay? In application layer data. So in Ethernet data frame, the IP header contains a 32-bit source address and a 32-bit destination address. The TCP header contains the source port number and the 16-bit destination port number. So many protocols used by data payload of IP packets to negotiate new ports and IP addresses. So after this negotiation is complete, communication parties establish new connections for transmitting our subsequent packets. So the negotiation ports and IP addresses are often random. Therefore, an administrator cannot proactively configure NAT rules because errors may occur with these kind of protocols during NAT. So the common NAT can translate the IP address and port numbers in UDP or TCP packet headers, but not fields in the application data payloads. So in many application layer protocols such as FTP and SIP, the TCP UDP payload contains the address or the port information and cannot be NAT. So here, the NAT ALG comes in to pass the application layer packet information of the multi-channel protocol, and they translate the required IP addresses and port numbers of specific field in the payload to ensure proper communication at the application layer. The example is that if you have an application that is using the FTP protocol and it requires both the data connection and the control connection, the data connection is usually dynamic and it is established according to the payload field in the control connection. Therefore, our LG needs to translate the payload information to ensure that proper establishment of the data connection. So here, what you should take out of this is that we use the ASPF. Who remembers the ASPF? Okay, so we use the ASPF function to implement this kind of forwarding policy at the application layer. What the ASPF does, it analyzes the application layer packets and applies corresponding packet filtering rules, whereas the NAT ALG applies corresponding NAT rules to the application layer packets. So ASPF interworks with NAT ALG, and therefore you can only run one command to enable both functions at the same time. Keynote or keywords to pick out of this, our packet header, ALG helps us to also translate our application layer information, but not only the information carried in our application layer data, but it also works with our ASPF. If you don't remember, I would kindly request you to go through the previous notes, I think the previous lecture, to remind yourself of what we looked at then. So this is how the NAT ALG implementation principle works. That we have our packet here, we have our host A, and it wants to access our FTP server. This is our private network, usually in the trust zone. And this is our public network, usually in our untrust zone. So it's going to set up a control connection between the host and FTP server. It's going to happen. Hey, you know what? this is my source address, and I want to communicate and send my packets to 8.8.1.1. So the host sends a port packet. After sending the port packet, which is now going to include the port packet, so LD processing is going to start, and the payload of the port packet has been now translated. So we're going to translate our port packet, and they're going to translate it into that port packet. So the FTP server then initiates the data connection to the hosts. Okay. Before that, the FTP server initiates a data connection to the hosts and sends back plus our translated port packet. And then when it is translated back, this guy is able to translate back our port to our original one. And the data is transmitted over our data connection. Okay. And also we are able to play around with our application layer information using the ALT, the NAT ALG application in FTP active service mode. So moving forward, we want to look at server mapping. Let us look at our NAT server, internal server. So NAT server function uses a public IP address to represent the private address of an internal server. So on a firewall, a public address is configured to represent the server's private address, and external users access the server through the public address. So you're going to get, this is the real IP address of our server on our internal network, but we are going to get a public IP address on our firewall, and we're going to configure it to represent this IP address. So when this guy is sending, this is the source. This is our source IP address. So this guy, when he's sending the packet, he knows that this is my destination IP address. I'm going to send it to that destination IP address. So when it sends, this guy will translate this information because he knows this public IP address of 202.202.1.1 is directly mapped to my internal. So this, when this NAT device receives that packet, it will translate it back to the real IP address of our IP address of all of our private IP address of our www server. So that's what it's going to do. So the firewall translates the destination IP address of external users request packets into private addresses of our internal servers, and the firewall translates our source addresses, or that are the private addresses of internal servers response packets, into public address. So even when you are sending it back, the firewall is going to translate this IP address into this IP address. And then because this is a public IP address, it will be able to be accessed externally. So this one is usually used to configure on servers which we want to access. And also we should take note that the server or the firewall supports security zone-based internal servers. We can configure firewall to provide access to external users on multiple network segments, or you can also configure multiple IP addresses on internal server based on security zone configurations. So by mapping different levels of firewall security zones to different external network segments and configure different public IP addresses to the same internal server based on security zones, you are able, or you can enable external users on different network segments to access the same internal server on your network. Let us look at the configuration. This is the configuration basically. So after the NAT is configured, the device automatically generates a server map entries, and the map that maps public IP addresses and private IP addresses. So what you do, this is, you just go into your command line prompt, just like you would open your ENSP. This guy is not on, let me just turn him on. Just like you'd open that. So you type in your NAT, after you accessing the server, you type in your NAT, you type in server, then you give the name, give it your name, server one, and you give a protocol, and the protocol would be TCP. It's a protocol that is going to be carried over IP. It's going to be global, and then you go ahead and give the IP address You give the IP address, the public IP address on your NAT, on your interface, and then the inside one on your local, or the real one on your server. You go ahead and configure that IP address and you hit enter. So when you're done, automatically a server map entry will be created, and it will look like this. You have the NAT server, any, which means global, and then the inside one is this. So if you have also gone ahead and configured the zone, it will be displayed, the protocol will be displayed. And if you have used VPN, it will also be displayed. And also the type will also be indicated. You're using NAT server reverse. If you're using any, and then it will be able to show you the two packets, one that is going out and also the one which is coming in, right? Coming into your server. So if you have configured it, you just go ahead on your firewall, and after opening this firewall, you log in. Let me clear my screen. You log in with admin. My new, I think it was HCIA at 123. Oh, authentication failed. Did I change my password? Let's try. Let me see. Admin.
HCIA 123.
HCIA 123. Oh, admin. Sorry. Don't remember my password. This is funny. I don't remember the new password I configured. Okay, let's see. Admin. And then you said it is HCIA 123. No.
At 123.
At 123. Okay, let me try one more time. Let me wait for it to. I hope it won't lock me out after numerous attempts. So admin, then HCIA at 123. Authentication failed. I don't know why, but I will look at that later. Let me try the default one. Admin, admin at 123. Okay. I think this is a new server. Sorry, new firewall. Let me change the password. Enter old password. Old password was what was the old password? Oh, it was admin at 123. And then the new password HCIA at 123. HCIA at 123. So before you do that, the moment you see this angle bracket, it means you are at the user level and you need to go in the system level. So when I enter that and I have my square brackets, then this is when I am able to pass my commands. So just go ahead and say NAT server, and say NAT server. Then I give it a name. It can be server A. And then from server A, I just go ahead and give the protocol. And in this case, I'm going to use TCP. And this is my external network. And I'm going to assign it a public IP address of 2.2.202.1.1. Sorry. Dot one, and then in my inside or my private network, I'm going to assign it an IP address of 192.168.0. Let's say 9. It's going to be on my management. So I go ahead and I give it and I configure it, and there I have already established my connection to my server by using that command. You can just go ahead also and follow those notes. Somehow basically a bit direct forward. So if I don't want to also capture the returning packet, so that I minimize that level of entries on my server map, what I will do, I'll just use the same command. Let me try to make this bigger. I'll just use the same command, but on using the same command, I'll also go ahead and use the no reverse command, so that I only capture, no reverse, that's a spelling. I'll use the no reverse command. Oh, the net name already exists. So I'll come here and say, let's say I configure it on server 1. I don't want to retype. I'll create one. So as you're configuring, you can always use that server already exists. Okay, you can go ahead and configure and you rename it and you use the no reverse command to be able to only capture the packets that are going out so that you minimize the entries on your server map table. I don't want to spend a lot of time on that. Okay. So this is what we have been talking about. So the server map and server map, this is part 2. After the no reverse is specified, the device generates only the forward server map entries, and it doesn't recall. Unlike this one, you see, we have 2 types. One that is coming in from our external network, and also one that is going out to our external network. So when you use a no reverse command, it only captures only generates the forward map entries, and it does not capture the the incoming command. So let us look at the typical NAT scenario configuration examples. We have our application scenario. We looked at source NAT, and we also looked at the NAT server. We can have our different zones, and we can have our trust zone and our demilitarized zone. This is usually the zone commonly on Huawei firewalls. So this is its IP address 192.1.20.1.24. Our untrust zone is assigned this IP address, which is a public IP address, and also our trust zone is assigned to that. So you can configure this, and all these are using your NAT device, and they can actually use one IP address that is going to access our private network. So when this device sends packets, this guy will go ahead and translate either based on port numbers, and then to be able to share the packets, or they'll go to the external one. Or if this guy wants to access, let's say our trust zone, maybe from our untrust zone, also his IP address will be converted into the public IP address, which will also come to our NAT and to be translated to our IP address, or the device which he wants to access on our network. Okay, so source NAT configuration on the firewall web. Basically, this is what you do. You just go to configure NAT address pool, and then you're able to add it. You say, I want to configure one. You give the range in your on your web, on your GUI. You go ahead and give the range, and then you configure. You can check PAT if you want. If you want to also do port address translation, you make sure it is checked.
It's a standing question.
Yes, please.
The source NAT configuration, the pool is to basically prevent or deny or accept given IPs that you provide to access the server. Is that the situation?
We have our public Hello, hello, hello. Can you hear me now?
Yes, can you?
Yes.
Okay, my internet is a
Yes, we
bit.
can hear you.
My internet is a bit shady. They are making some upgrades, but I'll beg that you bear with me.
Huh?
Okay. So we're saying that let's say your ISP, you can see my screen now.
Yes, we can see.
Let's say your ISP has given you 5 public IP addresses for you to use, right? And you're an enterprise, you have about 20 branches, right? Or you have about 5 departments inside, which each department having about 150 users. But you're going to use this pool, you're configuring, ideally you're setting your pool. Remember when we said in your address pool, if you are using port translation, you can have one IP address from this pool, let's say 202.169.10.3, and you can use it and you can have multiple devices using this while using our port address translation, right? Or you can choose to do without port translation. And only, that means only 5 devices can access the external network at the same time. When the 6th device tries to access without port translation, you will notice that it won't go because there won't be any public IP address available. I hope I've answered you.
Yes,
So
yes, thank you.
you're welcome.
I have a question, Mr. Sandy.
Yes, please.
Do you specify the number of private IP addresses per public IP address using import address translation?
It also depends on what you want to achieve, but it's always better to prefer the dynamic kind of way to minimize the kind of work that you need to do whenever you have a change in your network structure. You don't want to go always ahead and reconfigure your translation configurations.
Okay.
So configure source NAT IP policy. You still go to add NAT policy, and here in this example, the configuration enables users in the trust zone to access the internet resources of the untrust zone. Therefore, could you please mute your microphone? Therefore, the source security zone is trust and the destination security zone is untrust. So you can always go ahead and configure those details. Okay, just like you see that. So you can also go ahead and say, I want to pick my IP addresses in my IP address pool. Which pool has your public IP addresses? So let me clear this. So basically, this is just, you can go ahead and play with them and try to configure some of these. But let us look now at NAT server configuration when you're using the web. So you can also configure the internal web and FTPS using this. During NAT configuration, the external address is the public IP address, and the internal server provides for the external users. So the internal address is the IP address of internal server on your LAN. So you have your private IP address. This is the internal server on your LAN. And then this is your IP address, which you configure on your pool. And then you select the protocols, and then you go ahead and allow. If you want to use a public address for internal access, and then configure a backhaul. If you want to configure a backhaul route, right, you go ahead and check that. So configure an interzone security policy. Still, if you want to, remember we talked about zones and we said we can use a NAT server to configure the different zones. So you can also go ahead and play with these parameters, and you configure your interzone policies. You go to your web UI, choose firewall, select security policy, and then select forward policy. And under forward policy, you click on the policy list, and then you click add, and then you select your different parameters. Given the action, of course, is to permit. You make sure that the action permit is enabled on your service. So this is the same process, but how you can configure it on your server using the command line, the command line which we looked at. Remember the command line? Just double click on your server in your ENSP so that you have your command line, then you go NAT address pool. You say after that, you say section, you give it the range. It's running from 2.2.0 to 168.10.10 to 0.6. After that, you configure the policy, you send that policy. After you give the role name, you say NAT1, that is going to be a role name 1. Then you configure and say my security zone, I want it to be trust. Then the destination zone, I want it to be untrust. The source destination IP address is that. And then action, NAT group address pool 1, you want to permit it. So meaning you're actually permitting this address pool which you've configured on your firewall. Okay. Basically, configure the internal web and FTP servers. Still, you go through the same process. I don't want really to go through this. After you configuring your firewall and importing your file, just kindly make sure that you try out these commands on your firewall and then play around with them. So the application scenarios, we have the twice NAT. We have looked at the NAT server and source NAT. Now we want to look at the intrazone trust. The intrazone twice NAT. So simply the configuration of the route from a server to a public network, you can configure a source NAT based on the NAT server function. We have our internal server, we have our internet user. This is our public IP address. This is the real IP address, and this is the private address. This is the private address after source. So this is our real address. After that, you're going to first translate it from your DMZ to the private address after source NAT, and then this guy will also go ahead and translate it to that, and then it will be able to access the server. So in a NAT server configuration, the internal server can send a response packet only after the route destination of the private address is configured. So to simply configure without configuration the route destination of the public address, you can also configure the firewall to translate your addresses of external of your external user. So basically, as we have seen here, our trace NAT, the firewall translates the destination IP address of our user's request packet into private addresses of IHP server. In addition, it also translates the source addresses into the public address of the user. So the firewall will go ahead and translate the source address of the response packet from FTP server into the public.
现在是什么？我不听懂，Sandy，说了吗？
Hello, Mr. Sandy. We can't hear you.
I think the guy is off. I think he has a problem with his internet.
His network is not good.
But it's coming.
Language is Chinese.
Coming back. Just wait a bit.
Okay.
Oh, okay. Yes, listen, they will come back.
We're looking at the quiz. Which of the following are reasons why NAT emerged? Why NAT emerged? We have option A, which is insufficient IP addresses. We have option B, protection to real IP addresses from internal users. We have option C, requirements of specific services. We have option D, demand for easy device management.
A.
Someone is saying A. This is Jonathan.
No.
Joshua.
Oh, this is Joshua. Okay, Joshua Mwesigwa. Joshua Mwesigwa is saying A.
A also.
And someone else is also saying A.
A, B.
A, also A.
Saying A. Okay, is that all? I want us to move forward.
A and B.
A and B. Okay, the answers are A and B. One, they emerged because the IP addresses we all know they're not sufficient, so we need to translate our private into public. And of course, we also saw that one of the advantages, it helps us to protect our real IP addresses of our internal servers. So people are unable to attack our internal servers directly because this address over our untrusted zone is going to be translated into another IP address. So the answer is A and B. Okay, so let me close out of this and open our next module, which is going to be dual system hot standby. Okay. So